All right, so we've done some demonstrations for interfaces, interface implementation, and we had the sample, just overall for the syntax. When you have a subclass and a superclass, you use extends, and the limitation of extends keyword that you can only use a single inheritance in Java. You cannot extend multiple classes at the same time. However, you can implement multiple interfaces. And now you know that you can do more than just extending multiple interfaces. Interfaces themselves can be organized into a hierarchy of interfaces. Okay, so there's another demo here for book and product. The book class inherits from the product class and also implements printable. So all the syntax should be quite familiar. Typically, you use extends and then you use implements. I never tried to mix them. Let me try mixing them and see if syntactically it's possible. Right? So if I say class employee, oh, I don't have a super class, so we'll try it with some other example. Let's just move on with the presentation. So product, as far as I recall, contains code, description, and price, and the book also adds the author attribute, combines product with this author attribute, and we call superclass constructor, and we capture the author, and we of course implement the method which is supposed to be implemented based on our promise to provide every method implementation in that specific interface, and that just happens to be the print method. This sample doesn't include the override, but just be aware that override should always be used by you in modern programming, by all modern programming standards. A method that accepts a printable object is just using the printable interface name and using that object. This is something that we used in our example. In the main class, what we did was that we created an employee, and this is our object, and then we created a separate method. And in the separate method, we said that if your object here supports encryption algorithm and also provides us with the key, we can basically use this protocol of two methods here to say set encryption key and then encrypt. So I don't know how efficient this is. This is just all for the demonstration purposes. But you can see that I have an employee, which is an instance of employee class. But when I call make secure, I pass an employee, but it gets implicitly converted to an object of type I encrypt, which is just an interface with these two methods. And that's pretty much the intent, that make secure method is limiting itself only to the methods of I encrypt algorithm, and that's very, very practical, right? Because we don't want to over-design this method. We say that this method will work perfectly well for anything that supports I encrypt algorithm interface, and that is our case, right? Whereas employee, of course, implements secure in its own self, does decrypt, but then extends I encrypt, and in the end I encrypt provides those two methods that we've been using. Okay. Moving on. So interface inheriting other interfaces. So here's an example. We can use the extends keyword to combine interfaces, and this is an excellent tool to combat overblown, overinflated interfaces. When you have interfaces with multiple methods, it defeats the original purpose, that the purpose of an interface is to clarify things for everyone and express related methods under one roof and make them usable and obvious. So if things become unmanageable, you should start thinking about combination of interfaces, perhaps using a hierarchy of interfaces. And we basically were able to demonstrate that a little bit in our example. So we could also invent a couple of interfaces named product reader and product writer, relying on the sample code that we already had. So product reader would say get product and get product in form of a string, whereas the product writer would say add product, update product, delete product. So these would be clearly mutating style of access to our product, whereas those methods on this interface are just read-only, non-destructive, those that really don't change the state of an object, supposedly. So we mentioned constants already, that interface can include the constants, and for instance, we can use product constants, which would be the code, the description, and then we could use an interface that says product access, which uses extends, and it actually inherits all three of them. Okay, so this time we start with individual interfaces and then combine them into a single interface. So you can see that all kinds of combinations and design work can be done with interfaces, but then still you have to provide an object which will provide the true implementation for every single method that we're supposed to provide. Factory method is one of the design patterns that exist, which is extremely popular. The idea is to, instead of using new in your code, instead create instance of a class which implements interfaces, and the method is responsible, such as this get product access method demonstration here. It will generate an instance, create an instance using new of a very specific product, but then in the end it returns an interface back, right? So these are examples from our textbook, but you can already see, maybe you can see it, is that my habit is to name interfaces with an uppercase I in front of it, and I think it helps quite a bit to understand what the code does, especially that when we have non-trivial methods with different things combined. I prefer to isolate naming of my interfaces with an uppercase I in front of them. So we had the sample here. I don't know if you can sense it or not, but this is my practice, and that's what I do, and I've seen this done in many companies. But the textbook just uses normal conventional class names for the interfaces demo that they have in the book. So the benefit of separating interface from implementation is that the implementation becomes replaceable, right? So this product factory class, which uses the static method, which returns an interface from this specific method, could be based on other logic inside here, which will say if certain condition, create one class, else if another condition, create another class. So this method can be complicated based on some other factors that the caller of get product access doesn't have to know. In our case, we could demonstrate this by saying, let's also create a new Java class named manager, right? So we can have an employee and the manager. It's kind of classic, demo situation. So the manager extends the employee, and of course in normal under normal conditions we would say that by design the manager is the kind of an employee, because this is what inheritance does for us.